Now we're going to look at equations of normal lines. It's important to understand that the normal line is just the line that is perpendicular to the tangent line at the point where the tangent line intersects the curve. So for example, if we have this dotted line which represents the tangent line, notice it's tangent at this red point, meaning it hugs the curve at that point. The normal line is the red line. It also crosses through the red point, but it's perpendicular to the tangent line at that point. Okay, so we can't just slide the line up or down because then it wouldn't be perpendicular at that point. So basically the tangent line and the normal line come together at that red point, kind of like crosshairs. So we want to figure out how to find that equation at a particular x value for a function, which is what we're going to do here in example 1. It says determine an equation of the normal line for y equals 1/2 quantity x minus 2 squared at x equals 4. So you want to focus on this keyword normal, and that's going to be a different set of steps than finding the tangent or the secant line. Obviously for secant you need 2 x values. The first thing I would say is figure out what the y value is at that point. So just plug in 4 in here and you get 1/2 of 2 squared, which is 4. 1/2 of 4 is 2. So the y value would be 4, 2. But I just want to show you kind of what it looks like on the graph as we go through these steps. Now here's what the tangent line would look like. But we're not trying to find that, right? We're trying to find the normal line. So I'm going to make it purple this time instead of red. We want to find out the equation for this line. So you can see the construction order we just went through. Draw the point, draw the tangent line, then the normal line. But again, we don't have to do this, right, to figure out the equation. We can do it analytically. So we want to find an equation for this line. And I would say do it in y equals mx plus b form. So step 1 is to plug in the x value into the function. This will give you the y value of that point, which we can already see is 2, but we can show it algebraically that yes, indeed, the y value is 2. Step 3 is to take the derivative. So you want to take the derivative of your function using basically the power rule with a little bit of chain. There's really not much to it. So move the 2 out, decrease the exponent by 1, and multiply by the derivative of the inside, which is 1. So you get the derivative is y prime is x minus 2. Note, this does not give you an equation for the tangent line. No, this is an equation which gives you the slope of the tangent line at a given value. And just kind of a reminder, we've already done tangent line equations. To figure out the slope, you'd have to plug in your x value that you were given, and y prime would essentially be your slope. So we're going to go ahead and do that. Step 4, plug x into the derivative. Okay, so we plug in 4 into x right here, and we get 2. So that means y prime of 4 is 2, which means the slope of our orange line is 2. Interesting, right? Because that's also the y value. Doesn't normally happen that way. That only works for e to the x at every point. Anyways, so why would we try to find the slope of the tangent line if we're ultimately trying to find this slope? Well, if you recall back in geometry or algebra 1, if lines are perpendicular, then their slopes are negative reciprocals of each other. So I can now find the negative reciprocal of the slope of this line, which is 2. So for step 5, we're going to determine the slope of the normal line by finding the negative reciprocal of the tangent line. So basically what we do is we write 2 as 2 over 1, right? And then what we're going to do, and I'll use some arrows here, we're going to flip this and make it negative. So the slope of my normal line is going to be negative 1/2. I got the colors there wrong. This should be orange and the other one should be purple. I don't know why I did that. I want to be consistent. In the diagram I had the secant line is purple. So I mean the normal line is purple and the tangent line is orange. So my tangent line has a slope of 2 over 1, so my secant line has the slope of negative 1/2. I'm going to go back and be very, So this line has a slope of down 1 over 2. This line has a slope of up 2 over 1. Okay, good. All right, so step 6 is to write out the equation for a line y equals mx plus b. Step 7, plug in your values. We just found the slope, and we have a point. The point is at 4 comma 2. So 4 for x, 2 for y. Now we're going to solve for b. So for step 8, determine the y-intercept, which is b. So negative 1/2 times 4 is negative 2. And then add 2 to both sides. 4 is equal to b. You know what to do from here. Step 9, determine the equation. So write out y equals mx plus b. Just plug in your m and your b value. So the equation for the line. Again, I want to use purple because that's what it was on the diagram, on the graph. So the equation for that for the normal line is y equals negative 1/2 x plus 4. And yes, so there's your equation. That's in point slope form. I changed the app now to where it's slope intercept. Anyway, the equation for this line is y equals negative 1/2 x plus 4. And notice a couple things. Yeah, these lines are going to have different y-intercepts. So this one's going to cross at 4. And it's going to have a slope of down 1 and over 2. This one's going to cross somewhere else and have a slope of up 1 over 2. Yeah, so it crosses right here at 4, yeah. All right, so that's it for this example. If you have any questions about it, let me know.